Okay, so for this one you do not need a free body diagram because even though the weight's given and everything else, I did that to try to throw you off. It's 1 degree of freedom because it's 1 degree of freedom if you give me one value of one single dot term. I can find any other single dot term, etc. So in this case, you tell me theta, and I can find theta dot by taking the derivative, so I have a single dot term. So what you're looking for is a single dot result of velocity, so therefore I do not need a free body diagram, and so off we go. Okay, now, since that's what you're doing, you are given no dotted terms. You're given r and theta, and you want to find speed. So what do? You take the derivative of this stuff. So that's what I'm going to do. Now, what coordinate system do you want? Do you want to use x and y, tangent normal, or r and theta? I think it should be obvious to you that you should use r and theta. Now you want velocity, so you want speed, which is the magnitude of velocity. So I'm going to find velocity. Velocity in polar is equal to r dot in the radial direction plus r theta dot in the transverse or theta direction. Okay, and in the radial direction you don't really need them, you don't really care, but it's that way and perpendicular. So this would be the n theta. That would be the nr. Okay. So, what I'm looking for is r dot. Well, I know r is equal to 2 plus cosine theta. Alright, and so if I take a derivative of that, then I'm going to need the chain rule for that. So the derivative of cosine is minus sine of theta times theta dot. Now, that's all I need is, one dot terms, so I'm not going to bother to go any further. Theta dot, well, I guess I should write it down, right? So theta is 0.5 times t squared. So now take a derivative of that. You don't need a chain rule because you have t over there. So theta dot is equal to 0.5 times 2 is 1 times t. And that's all I need for that one. So theta dot is t. Okay. Alright, so let's see. Now let's just plug and chug. When t equals, okay, so here we go. So velocity is equal to r dot. R dot is equal to minus, well, okay, let me put in some values. You want these values. I'm going to plug them into here, here, and here. So I need to find those values when time equals 0.5. So the first thing I'm going to do is I'm going to find the value of theta. So this is 0.5 times t is 0.5. No, it's 1.5. So t is equal to 1.5 squared. And those are going to be in, theta is in radians. So this is radians. So when you punch it into your calculator, make sure that you punch it in correctly. So theta is equal to 1.125 radians. And to go from that to degrees, that'll be 1.125 times 180 degrees for pi radians. And so that is equal to, let's see, 64.4 degrees. 64.4 degrees. Okay, so then I can plug it into my calculator easier. Okay, plugging values in here, theta dot is 1 times 1.5, that's a 1.5, and that'll be radians per second, just like it has always been in all the homeworks, right? Now, to get the r, you simply say it's equal to 2 plus the cosine, and probably your calculator's on degrees, like mine was, so you want to use the theta in degrees. Okay, so I got an r which is equal to 2.43. Okay, so now that I have all these numbers, I just plug it in. V equals R dot. Oops, I've got to get the R dot. Okay, so the R dot is a minus sign of 64.4 times theta dot. Theta dot is 1.5. Oops. Theta dot is 1.5. Yeah. And I punch that into my calculator. I got R dot was a negative 1.353. So let's see, R dot is a negative 1.353 in the R direction. And it is R times, so that would be 2.43 times theta dot is 1.5 in the n theta. And you want speed, which is magnitude. Determine speed. So the speed is the magnitude of that, which is the square root of 1.353 squared plus, let's see, let's check out, that's a 3.645 squared. And I get that that's equal to 3.889. And that's it for this one. Okay, so this is 3.889.